So here's a tutorial to help you with some of your proving trig equations. For question number 4, we want to show that the left-hand side is equal to the right-hand side. So the first step is change everything to sine and cosine. So instead of cosecant, I'll write 1 over sine. And instead of secant, I'll write 1 over cosine. And instead of tangent, I'll write sine over cosine. And when those two are written right beside each other, that means we're multiplying them. Okay, so on the left-hand side, when we multiply two fractions, we can just multiply the numerators. 1 times sine is sine. Multiply the denominators. Cos times cos is cosine squared. And then, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal. I just take the denominator and take the reciprocal. So the left-hand side is equal to cos squared over sine. On the right-hand side, I want to make a common denominator of sine. So I'm going to multiply the second fraction on the top and the bottom by sine. And then I get 1 over sine minus sine squared over sine. So now I can put the two numerators together. 1 minus sine squared over sine x. And because cos squared plus sine squared is equal to 1, that means 1 minus sine squared is equal to cos squared. So cos squared x over sine x. Both sides are the same. Voila. For question number 6. Normally I change everything to sine and cosine, but because there is a relationship between secant and tangent, here it is. 1 plus tangent squared is equal to secant squared. I'm going to avoid changing this one to sine and cosine. 1 plus tangent squared is secant squared. There's probably a shortcut by using this formula. Okay, so in my head I'm thinking that secant is A and tangent is B. Really, this equation is A to the power of 4 minus 1 over B squared equals 2 plus B squared. Now, A to the power of 4 minus 1 is actually a difference of squares. I could write that as A squared minus 1 and A squared plus 1, because A squared times A squared is A to the 4, and negative 1 times positive 1 is negative 1. The middle terms cancel off. So I'm going to do that on the left-hand side here. I'll factor secant squared to the power of 4 minus 1 as a difference of squares. So I'll write that as secant squared minus 1 and secant squared plus 1. So let's see, secant squared minus 1. If I move the 1 to the other side of this equation, secant squared minus 1 is tan squared. So instead of secant squared minus 1, I'll write tan squared. And then on the left-hand side, the tan squareds cancel. And I'm left with secant squared plus 1. But secant squared is equal to tan squared plus 1. So instead of secant squared, I'll write tan squared plus 1. And then I still have plus 1, which is tan squared plus 2. Yay! For question number 8, I don't have a nice connection between secant and tangent for this one. I think I'll probably change those tangents into sines and cosines. And usually that's what you do. And you could also solve the previous problem by changing it to sines and cosines, but it's just faster to do it that way. Then I want to make common denominators. So I'm going to change those 1s into cosine over cosine. I'm going to multiply the 1 by cosine on the top and the bottom. I'll change the 1 in the denominator to cosine over cosine so that I can put those two fractions together. So on the top I have cosine plus sine over cosine. And in the denominator, I've got cosine minus sine over cosine. So now I can multiply the top and the bottom of the fraction by the lowest common denominator to get cosine x plus sine x over cosine x minus sine x. I didn't even have to do anything to the left-hand side. Okay, so again, if you get stuck on something like this, you can think 1 plus a over b over 1 minus a over b. And if you simplify this fraction, oh, actually the easiest thing to do probably would be to multiply everything by b right from the beginning. And then you would get b plus a over b minus a, which is cos plus sine over cos minus sine. So I could have done this one even faster. For question number 12. Okay, the right-hand side is already in its simplest form. We have 1 plus sine x over cos x, cos cubed x. And on the left-hand side, we have 1 over cosine instead of secant over 1 minus sine. So let me multiply everything by the lowest common denominator, which is cosine. And then on the numerator, I'll get 1, and the denominator, I'll leave this one factored, cos times 1 minus sine x. Okay, and when you see this 1 minus sine x on one side of the equation and 1 plus sine x on the other side of the equation on the other side of the fraction, this is when you know that you need to use the conjugate. Or I can choose to multiply by the conjugate on either side. So 2 conjugates would be 1 plus sine x is a conjugate with 1 minus sine x. So when you see these 2 conjugates on opposite sides of fractions, on opposite sides of the equation, then what you want to do is you want to take one of those and multiply by its opposite. So I can multiply by 1 minus sine x. And I'm going to multiply by the same thing on the top and the bottom so the fraction doesn't actually change, just multiplying by 1. Now, if I wanted to, I could also have done 1 plus sine x on this side. It would give the same thing. I can't do both at once because then I'll be changing this one to that form and vice versa, and I'll be stuck in the same position that I am. I got to do this to one side only, but it doesn't matter which side I choose. I can do the conjugate on the right side, or I could do the conjugate on the left side. So I'm going to do it on the right side since I have more space there. So I'm going to expand the numerator. 1 times 1 is 1. 1 times sine is sine. Negative sine times 1 is negative sine. And negative sine times positive sine is negative sine squared. So the middle terms cancel off. I'll leave the denominator in factored form. Now 1 minus sine squared x is the same as cos squared x because cos squared plus sine squared is 1. So in the numerator I get cos squared x over cos cubed x, 1 minus sine x. So again, you can think this is like b squared over b cubed, 1 minus a. So the b's will cancel off. 2 on the top will cancel with 2 of them on the bottom, leaving us with 1 over cos x, 1 minus sine x. Now let me do it again, but this time I'll use the conjugate on the left-hand side. So I'll do exactly what I did before, change the secant to 1 over cos, then multiply the numerator and the denominator by cosine, get rid of that complex fraction. And now because I'm trying to get 1 plus sine x in the numerator, I'm going to multiply the denominator and the numerator by 1 plus sine x. So that gives me 1 plus sine x times cos x, 1 plus sine, 1 minus sine. Okay, so in the denominator there I have like something of the form 1 minus a, 1 plus a, which is difference of squares, 1 minus a squared. So 1 minus sine times 1 plus sine is 1 minus sine squared. And 1 minus sine squared is the same as cos squared, because cos squared plus sine squared is 1. So 1 minus sine squared is the same as cos squared. Cos squared times cos is cos cubed. So that's how I can turn the left-hand side to the right-hand side. It's just another way of solving the problem. And finally, for question 16, it's starting to look very similar. I'm going to change everything to sine and cosine. And then I'll multiply everything by the lowest common denominator on the top and the bottom of the fraction to get rid of these complex fractions. I'll leave the denominator in factored form. That helps me to cancel anything. Cos times 1 over cos is 1. Cos times 1 is cosine x. I'll leave the denominator in factored form. Okay, so now I recognize that on one side of the equation I have 1 minus cosine, and then on the other side in the numerator I've got 1 plus cosine. So I have conjugates in the numerator and the denominator of opposite sides of this trig identity. So this is when I'm going to need to choose a side to multiply the conjugate by. I'm going to choose the left-hand side because it's more simple than the right-hand side. So I'll multiply the left-hand side by the conjugate, which is exactly the opposite of what I have here. I'm taking the exact same binomial and just changing the middle term to positive instead of negative. Okay, and when I do that, I get 1 plus cosine x in the numerator, which is exactly what I want. Now the numerators are the same. In the denominator, I have 1 plus cos times 1 minus cos, which is just 1 plus a times 1 minus a. If I FOIL that out, the middle terms are going to cancel, and I get 1 minus cosine squared. Okay, 1 minus cosine squared is the same as sine squared, because sine squared plus cosine squared is 1. And now both sides are the same. Fantastic.